I was impressed that with material science up here, they're integrating physics, chemistry, and engineering into a single program, whereas looking at other universities, you end up having material science that is born out of, say, a physics department or a chemistry department or a mechanical engineering department. But material science isn't just one of those fields. It's all these different scientific fields into a single area, and WSU did an excellent job at combining all those areas together.
Well, the best thing for me working at my PhD in WSU is I feel like it has all the equipment and all the faculty and people I need to succeed, not do well on my own.
When I came for my visit, I loved everyone that I met with. We just clicked right away, and it was so much fun.
All interactions have been very good, very helpful, very laid back, I guess, so to speak. And then other grad students, it's great. Everyone's friendly, willing to help.
Our faculty belong to the different departments on campus and come together to work as part of the program voluntarily, which means that this is a group of people which is self-assembled. They are there because they're excited about working with each other, using the shared facilities, using the shared resources.
All of these systems really have become possible because of major advances in materials. And so materials are really kind of an enabling technology that allow us in society and engineering to go forward.
I've had students in the past from material science, mechanical engineering, physics and chemistry. So as a part of this program, I'm happy to help the program because I believe that advanced materials and development in material science is really the name of the game in the 21st century.
We don't have the solution. We talk to them, this is the challenge, this is the area we're working on, and we would like them to contribute. And the contribution should come not just physically, just going in the lab and just running a few experiments on the machine, turning the knobs, but also intellectually contributing, okay, what they're getting, how they're improving, and so on.
Lab facilities which are absolutely state-of-the-art. Every student of ours is fully funded, every graduate student is fully funded. And the labs are really well maintained and well resourced. And of course the students also get opportunities to travel to conferences both nationally and internationally. All of those are bonuses of working in a program which is well financed.
The problems that we address primarily are how to manufacture metals so you can make those with the least amount of material possible so that it's light, so that it's strong, so that it can survive under extreme conditions.
And we have a number of different projects that span both from physics into material science into biotechnology. One of the areas that we focused on in the last few years is in the area of crystal growth, and partly that's because Washington State grows more single crystal materials than any other state in the Union.
We work in the area of manufacturing and materials processing. These are advanced materials, the hard materials like metals and ceramics and composites like that. Most of our work is focused in the area of applications like biomedical or aerospace areas. So in the area of biomedical, we focus in working on biomedical devices like load-bearing implants, hip implants, knee implants, and how we can make them better.
In our lab, we not just look how materials work in biology. We learn from biology and we apply that knowledge to industry.
All of our students, they go to conferences to present their data, give talks and oral presentation as well as poster presentation. It also makes them comfortable and teach them a lesson how to teach to a scientific audience. It is very important other than just writing papers. So all our graduate students, we give them at least one opportunity, sometimes two, to attend an international conference.
Last summer, went to a magnesium conference up in Vancouver, BC, and exactly the same thing. Got a bunch of suggestions, met a bunch of people. You have people tell you, "Oh, you're doing this wrong." You're like, "All right, I'll change this." But as far as developing professionally, it's certainly WSU certainly is a good place to do it. I feel every time I've gone to a conference, people at least know who you are, so that's at least a step through the door.
We create internship opportunities for our students in both industry and in national labs. In particular, we have a program which you can look up on the web called the WARIAC. WARIAC is the Washington Alliance for Research Internship in Advanced Characterization. This is a program that we jointly run at PNNL, which is a national lab, the Pacific Northwest National Lab in Richland.
The diversity of the department, interdisciplinary, and how I'm working on semiconductors, but my friend's working on, mechanical properties, and we can help each other out, and it's like encouraged, and I really like that. It allows you to learn a lot more, experience a lot more, and gain a more diverse skill set.
As for my group members, even though we don't do too many things together, I think we get a lot of times to talk about not the research or do stuff together, but a lot more on the equipment.
The best thing about working on my PhD at WSU is that I get the chance to explore everything I want to explore in the lab and try to solve some problems.
The platform we're working on is a biochem process. So what that means is we take our feedstock and we break it down with biological and then chemical processes to go to an alcohol, and then chemically convert that alcohol to a fuel. And so there's residuals in the material that can't be converted to an alcohol, and so they have potential then to be converted to polymers and resins and other chemical products.
We study how materials behave under extreme conditions. This has a lot of benefits for obviously national security. It has a lot of payoff for fundamental science. It's a very broad area of research, but at the end of it, it's about understanding materials at extreme conditions.
We look at semiconductors, especially those semiconductors that are used to emit light very efficiently, such as ultraviolet or blue light, and that can be used for white light emission applications, so replacing the incandescent bulb. And we're really interested in the fundamental properties of semiconductors.
Another topic for my research is advanced lithium-ion battery materials. We know we have some safe problems for the lithium-ion batteries. We want to develop some safe and ultra lightweight and long lifetime lithium-ion batteries.
The best part about being in this program is the kind of candidate pool or the student pool that we get. So that is, I feel, the students' diverse background is the best part of being a part of interdisciplinary program.
The person's personality, their interpersonal skills, their ability to collaborate in large teams, which are almost critical in today's interdisciplinary research world. Whether you are in academia or whether you are in a national lab or whether you're in an industry, you're expected to work in teams, and that requires some human qualities.
Like the new student, I want to know what's the possible future, either industry or academia, so I can know how I can help them.
And I believe that in the future, virtually most scientific problems will be of a multidisciplinary character. So the graduate students here have a huge benefit. They can talk to a physicist, a chemist, a material scientist, a mechanical engineer, and that teaches them a lot of different things.